In this video, let us see hypothesis testing using two-way ANOVA. ANOVA is a statistical technique used to check whether the means of more than two populations are equal. Let us consider a problem. Here, the following data represent the number of units of a product produced by three different workers using three different types of machines. So here three different machines are X, Y, and Z, and the workers are A, B, and C. The problem asks whether the mean productivity is the same for the different machine types and whether the three workers differ with respect to mean productivity. So it's a two-factor test. So here, why it's a two-factor test? Here we want to test whether the mean productivity is the same for different workers, as well as we want to see whether the mean productivity is same for different machines. So that is why it is said to be a two-factor test, or here it's a two-way ANOVA. So before proceeding to test whether the mean productivity is same for different machine type, as well as whether three workers differ with respect to the mean productivity, we need to form a null hypothesis. How null hypothesis can be considered in this problem is, let us assume mean productivity is same for three different machines and the three men do not differ with respect to mean productivity. If this null hypothesis is false, then we need to accept the alternative hypothesis. What will be the alternative hypothesis? The mean productivity is not same for three different machines and the three men do differ with respect to mean productivity. So now, in order to simplify the calculations, so we can also subtract 30 from each given value. It is not a must and rule that we need to subtract 30 from each given value. This is only to simplify the calculations. Okay. So why I'm subtracting the 30 is, so if we square this data, see here we have got 28 and 36, 32, and then 38, 28. So these are two-digit number, which are little bit bigger number. And then when we go for squaring this data, sometimes we may do mistake. So in order to simplify our calculations, what we do, we shall subtract from each data the 30 figure. It is not must and should rule that you need to subtract from 30. So you can subtract from 20, you can subtract from 36, you can subtract from 38, you can subtract from 40, which is not there in this data set. Whichever is comfortable for you, you can use it. It depends upon which number we are comfortable to subtract all the data. So here almost all the data are nearing to 30. So what I do is, I do subtract all this data with 30. So how do we do? So 8 minus 30. So we have to do, so therefore I'll be getting it as minus of 22. So similarly 28 minus 30. So therefore I'll be getting it as minus 2. 6 minus 30. So we'll be getting it as minus 24. So similarly 32 minus 30, we'll be getting it as 2. 36 minus 30, which is equal to 6. And then 28 minus 30, which will be equal to minus 2. So similarly, for the Z-SAM machines data, I have subtracted with the 30. So 20 minus 30, I'll be getting it as minus 10. 38 minus 30, I'll be getting it as 8. And then 14 minus 30, I'll be getting it as minus 16. So for all these samples, so let us find the square of each sample. So let me call this as x1 square. So minus 22 square is 484. Minus 2 square is 4. And minus 24 square is 576. Similarly, for all the x2 sample, let us find the square of this value. So that is x2 square. So 2 square is 4. 6 square is 36 and minus 2 square is 4. So similarly, so for all the data samples x3, let us find the square. So therefore x3 square. So minus 10 square is 100, 8 square is 64 and minus 16 square is 256. Now what you do, you add all these values, sample values. Okay. So x1 total if you find, it will be equal to minus 48. Similarly, total of x1 square will be equal to 1064. Similarly, x2 total when we do it is 6 and then x2 square total when you do 4 plus 36 plus 4 will be getting it as 44. And total of all the x3 samples minus 10 plus 8 minus 16 which is equal to minus 18 and total of x3 square 100. 64 to 56 will be getting it as 420. So now we have to find your row total also because it's a two-way ANOVA. So two-factor test. Therefore, we need to find the row total. How do we get minus 30 here? Take the sum of minus 22 plus 2 and minus 10. We'll be getting it as minus 30. So similarly, how I'm getting at 12? 12 is the total of minus 2. So x2 sample, so plus 6 and then plus 8. So this is how we'll be getting it as 12. So similarly, to row total, the third row total is minus 42. How do I get minus 42? I need to sum minus 24. So here x3, x1 sample minus 24 and then x2 sample, so which is minus 2 and then adding the x3 sample, so which is minus 16, which comes under the third row. So adding all this data, I'll be getting it as minus 42. So this is how we have to construct the table initially so that it becomes easier for the next procedure. So after this, let us go with the algorithm. So the algorithm says, find the total of all the individual items. And this is called as T, the total sample values. So we have got here 3 samples. So therefore, total of x1 plus total of x2 plus total of x3. So total of x1. So we have already, for this purpose only, it's better to construct the table so that it becomes easy. So total of x1 is minus 48. Total of x2 is 6. And total of x3 is minus 18. So when we add all this, we'll be getting the total value as equal to minus of 60. So after this, we need to find the correction factor. So correction factor is given by t square by n. So here t square. So total of t value is 60. So therefore 3600 divided by n. So why this is 9? So it is 9 because from the machines we have taken total samples, right? So total sample row wise and the column wise, we have taken only 3, right? So 3 plus 3 plus 3. So totally we have taken 9 samples. So therefore here n value is equal to 9. So therefore t square by 9 will be getting it as 400. So after this step, we need to find SST. So what is SST? SST is sum of squares of the total samples. So which is SST. So SST is x1 square plus x2 square plus x3 square minus C. What is C here? C is the correction factor. So for this purpose, we have already made a table. So x1 square is 1064 and x2 square is 44 and x3 square is 420. So substituting all this and then minusing with the correction factor, which is equal to 400, we get the SST as equal to 1128. So SST is sum of squares for total variance. So which is equal to 1128. After this, let us find sum of squares between machines. So sum of square between machines is given by as SSC, and that is given by the formula x1 whole square divided by n1 plus x2 whole square divided by n2 plus x3 whole square divided by n3 and then minus of the correction factor C. So x1, total of x1 we already done this table, right? So total of x1 is minus of 48 and total of x2 is 6 and total of x3 is minus 16. So substituting that, and then here n1. So as I said already, n1 is the number of samples we have taken from for each workers. So each workers we have taken 3 samples. So therefore n1 value is 3 and n2 value is 3 and n3 value is also 3. So then add all these things and then subtract with the correction factor, we get the SSC value as 488. So after this step, we need to find sum of squares between workers, and that is given by SSR, which is equal to total of TJ whole square divided by K minus of C. So now what is this TJ? TJ is the sum for each row total. So we have already done in this table, right? So each row total value. So row total for the first row is minus 30 and for the second row is 12 and third row is minus 42. So substituting that, we'll be having x1 is minus 48. So minus 48 square and x2 we saw it is 6 and x3 value is minus 18. And now what is the, we are coming to this row, right? Sum of squares between the row. So row total we saw minus 30 square plus 12 whole square and minus 40 square. Then divided by K. So what is this K? So K is coming back to this problem. What is K? We have got here workers, right? So how many workers are there? A, B, C. We have got 3 workers. And for 3 workers, the samples we have considered is the productivity for the 3 workers. The sample we have collected is 3, right? For the machine type X, we have taken samples. And similarly for the machine type Y, we have taken the samples. And similarly for the machine type Z, we have considered the sample. So total number of samples collected for each workers is 3. So this is what we are defining here, the value of K. Our K value is equal to 3 and minus C, correction factor we have calculated in the previous steps as equal to 400. So subtract that. So totally we'll be getting it as 536. So this is our SSR value. After this, let us find sum of squares deviation for residual, or we shall call it as error variance. So error variance is given by the formula SSE is equal to SST minus of SSR plus SSC. So all this we have already calculated just now. So SSE will be equal to SST. So SST value we have got it as 1128, and then we have to find SSR value. SSR value is 536 and then SSC value similarly we have calculated as 536. So calculating all this we'll be getting as 104. So after this we have to go with degrees of freedom. The degrees of freedom is given by the formula V1 is equal to K minus 1 and V2 is equal to R minus 1 and V3 is K minus 1 multiplied with R minus 1. What is K? K already I have explained what is K here. K is the nothing but the number of groups, right? So number of groups. How many groups we have got? We have got 3 workers, right? So if you go with the previous statement of the problem, how many machines we have got? We have got the number of machines as X, Y, Z. Only 3, right? So therefore, now our K is equal to 3. And next, similarly, we have in the formula R also. How many R's? R is also equal to 3. What is this R? R represents the workers, right? So we have got 3 different workers. So therefore, in this problem, K is 3 and R is also equivalent to 3. So substituting that, 3 minus 1, we have got 2. Similarly, R is 3 here. So 3 minus 1, 2. And V3 is K minus 1 into R minus 1. So K minus 1 is 2 and R minus 1 is also 2. Therefore, V3 value is equal to 4. So after this, we have to find variance or mean square between samples. So MSC, so which is equal to SSC divided by V1. So in the previous steps, we have calculated SSC as 488 and V1 as equal to 2. So therefore, the equivalent answer will be equal to 244. So similarly, now find variance or mean square within sample. And that formula is given as MSC is equal to SSE divided by V1 into V2. So SSE is 104 and V1 and V2, as when we saw V1 is 2 as well as V2 is also 2, which we have seen in the, we have calculated, and therefore the value will be equal to 26. So after this, we need to find MSR. MSR is SSR divided by V2. This is with respect to the row, right? So SSR divided by V2, and that is equal to 266, 268. So now we shall find that F ratio between columns. That is nothing but between columns means it is between machines, right? So we have taken the machine as X, Y, and Z, right? So between machines, so FC, F ratio between columns. That's why I have mentioned here FC, and with respect to the degrees of freedom, V1 and V3. So MSC divided by MSE. So we have calculated MSC as 244, right? Our MSC is 244 and divided by MSE. So MSE we have calculated as 26. So substituting that and then simplifying, we get F ratio between columns as 9.38. So this is nothing but our calculated value. So similarly, we shall see F ratio value or F calculated value between workers or between rows. So between rows, the formula is FR with respect to the degrees of freedom V2 and V3. So it is MSR divided by MSE. So MSR we have calculated as 268 and MSE is 26. So simplifying, we get 10.31. Now these are nothing but the calculated F test value. Now we have to check the table value. So table value, how to check? Our V1 is 2 here, right? So here we have calculated V1 as 2 and V3 as 4. So now V1 as 2 and V3 as 4. So V1 as 2 and V3. V3 is nothing but here V2. Let us V3 as 4. Sorry, V3 as 4. So now for with respect to that, the calculated value is 6.94. This is the standard value. The standard value or the critical value with respect to the level of significance 5%, we get the table value or the standard value as 6.94. So if we can see here, so in this problem, both the degrees of freedom, we got it as 2 and 4. So here V1 also 2, because with respect to the row, we have to consider the degrees of freedom as V2 and V3, right? So, but in this problem, we saw that V2 is also 2 and V1 also 2. So, therefore, the table value is same for both the row as well as row wise as well as the column wise. We want to check the table value is same. The table value is 6.94. So, now let us see how we can conclude the result. Okay. So since the calculated value, see here our calculated value for between the machine types, whether there exists a significant difference in the mean productivity of the machine. When we want to check that, our calculated value is 9.38. But what is our table value? The standard value is 6.94. So calculated value is greater than this 6.94. So therefore, we conclude the null hypothesis is rejected because the calculated value is greater than the standard value the null hypothesis is rejected. So that is why we conclude that the mean productivity is not same for three different types of machine. The mean productivity among the machine varies. Similarly, let us see the table value for with respect to the degrees of freedom 2 and 4, we got it as 6.94, and then our calculated value, right? So with respect to the between workers, we saw the calculated value as 10.31, right? So 10.31, this is the calculated F test value, and this is greater than 6.94. So therefore, we can say that the null hypothesis is rejected. That means we can conclude that workers differ with respect to the mean productivity. That means mean productivity among the workers is not same. So here we have taken the workers as A, B, C, and we see that the mean productivity among the workers is not same. It differs. So this is how we conclude the conclusion. We come to the conclusion that the mean productivity among the workers as well as among the machine is not same.